Okay, so this is going to be our video discussion here over the On Your Own practice for Chapter 2 and Chapter 3. I'm here with my daughter, Braylon.
Hi.
She's going to help us read through a few of these and give us a little bit of her input on it.
Mm-hmm.
So, let's take a look here. All right.
A is if 2x plus 5 equals 11, what is the variable of 2x minus 5? Oh. A is minus 11, negative 6, 1, 11.
Alright, so those are our choices. So here, we'd solve this first equation here, and then plug in that value, which we would get 3, plug it in to get the final answer of 1.
Mm-hmm.
Alright, for this one here, we're looking for the cost of a single bulb. So key idea is kind of approximating. It's in between 0 and 2. And looking where it intersects that line here, we see we have a scale of 1 when we're counting. So it's right around 2, it looks like. So 1, 2, 3, 4, right? So our closest answer to 2 is going to be B. Sorry, pop up there. Okay, look at number 3. Key idea here is I actually made a little bit of a mistake here. I circled the wrong one. So we're given it's 50 per half hour. And then it says H is the number of hours. And there's this whole bit here. They don't make anything until after they've danced 3 hours. So what it should actually look like here is we'd start off with 100 times, so parenthesis, H minus 3. And then what we'd want to do is we're going to distribute that. So 100 times H gives us 100H, and then 100 times minus 3 gives us negative 300. Okay, so in this one we're given a graph here, or a table I should say. So we have G represents the number of pounds of grain, so that's our dependent variable here. And D represents the price, so that's our independent. So this is like our X column, this is like our Y. So if we want to figure out our equation here, we want to find the slope and the y-intercept. So key idea here is when we use that dependent variable as our y, this is our x, so we plug into the slope formula, and then we'd go ahead and solve for our y-intercept by plugging in an m as well as an x and a y. And again, you can use any ordered pair up here. On to question 5 here, we have our equation we're given. It says if the equation above has infinitely many solutions, and c is a constant, so just a consistent term, a whole number, decimal fraction, whatever it may be. Basically, it's not a variable. What is the value of c? So, first bit here is we're going to go ahead and realize that if we have infinitely many solutions, the constants need to cancel out, meaning that they're going to be the same number on each side. So, if we distribute this 2 a bit here, and distribute our c to both terms, we have 2x minus 5 is equal to 4 over 5c times x minus 2c. So our variable terms here, they're going to end up being the same thing. So these constants also have to be the same to have that exact same thing. That's what infinitely many means. Both sides are the same. So if I think about setting those equal, I could have negative 5 is equal to negative 2c, and if we solve, we'll end up with our answer. So again, just kind of applying that linear vocab. Okay, question 6, we have if a is a rational number where a is greater than 1, which of the following could be a graph of that equation? So it's not much use to us there. So if we kind of rework it a bit, it's linear, we see all the variables have an exponent of 1, a is just some number, we can go ahead and try and make it look a little bit more friendly to us. So let's get it y by itself. So we could subtract it over, factor out the y, factor out our x, and then divide everything by 1 over minus a. Then we kind of see that we got something positive here. So the last step here with this now is that we know that a is greater than 1, meaning anything I plug in here is going to be negative, right? Because the top's going to be positive, but 1 minus something bigger than 1 gives me a negative. So this is a negative number, as is this. So the only graph that makes sense with that would have a negative slope and a negative y-intercept. That'd be a pretty challenging problem. Definitely something I would save till the end. Alright, for number 7, what value of n satisfies the equation? Just kind of showing some intermittent steps there. You can see that this is a problem that they're saying you don't necessarily going to be guaranteed a calculator for. So again, making sure we know how to reduce those fractions there. Alright, looking at 8. We have a freight airline charges a flat fee to airmail a box, plus an additional charge for each pound. The graph above shows the relationship, etc., etc. Based on the graph, how much would it cost for a 40-pound box? So first thing we're looking at here, you can kind of see that flat fee, or that initial cost there, when we have a 0 weight. So that'd be about $10, right? So right there. Then we could get our slope. So if I picked some good whole numbers, so 0, 10, then at 4, 16, we'd see another good, nice intersection there, right? So it crosses the nice grid lines. Don't use anything that's like in between. So there we'd find slope, and then plug in 40 for our x there to get our y. Alright, here, the gist is it tells us what year we started in, so it's years after 2014. And it says, in what year should the increase in property values start to slow down? So it doesn't necessarily go negative, it's just where it's starting to slow down. So if we can look here, we kind of see that lessening in the slope. So here it's pretty steep. Here it flattens out a bit. So if we're looking at the year 2014, that's about 8 years in. So our answer would be 2022. Alright, number 10. The graph above shows the cost of joining and buying music from a music subscription service. So here it says, what does the y-intercept of the line most likely represents? The y-intercept is always just kind of a vocab terms here, like our starting value or flat fee. So the closest thing to that is the cost to join, right? Going in here, it says 120 for a day's work and 25 for each cruise. So the idea there is for each represents a slope in a linear equation. And then that 120 is kind of like the base rate. So each day gets that. Here's another one. Which value of x makes the equation true? So just solving. If you need more practice with solving, feel free to reach out to me. I'd be happy to kind of work you through the steps. The back of this book also provides like the justification and kind of logic, or the way they would suggest solving as well. Okay, on to 13 here. We have Henry just set up a direct deposit from his employer to his checking account, and there's the equation. It basically says here which was likely to be true here. So it says Henry earns 126.13 per week. It's not the case. So the per would be their slope, right? So it looks here it's like he's earning about 360. An initial deposit of this, well, if you're putting money in the account, it's probably not negative. This one makes more sense, right? Before setting up the direct deposit, he had overdrawn his account, right? So it's actually a negative number there. He owes some money. So in this scenario, again, knowing positive, negative, what that represents. Here, this is typical. We count our slope. We see it's 1/3, and our b there is at -4. So pretty basic on that one. So y equals mx plus b is going to come up about 5,000 things, or 5,000 times, I should say. Okay. Here we have Jose is using his laptop and wants to recharge it before the battery completely runs out. He recorded the battery charge for the first 30 minutes after he plugged it in to get an idea of when it would be completely charged. So he's estimating how long it's got to be plugged in for, which I think all my students should do. And then we're trying to figure out about how it looks. So here, pretty basic. Let's find the slope here, right? So minutes would be our x, percent charge is our y. We find our slope. It's we'll actually get 1.5 for the slope. So if you do things correctly and you're confident, you really can kind of shortcut a few problems here, because I could look and say, okay, there's only one with a slope of 1.5. Alright, so this one here, we're figuring out when two different packages are going to be equal. So the unlimited package is 325. Pretty steep, right? But then again, laser tag's pretty awesome, so it's kind of worth it, I guess. The second package has a $125 enrollment fee. You get 5 free visits. You'll notice that's uncommon, the whole idea of getting things free or things not starting until a certain number. So that whole idea of free visits, that means we have to reach a certain number. So that usually signifies our subtraction. So we're looking for the cost to be the same. So here I have 325 is equal to 8, because it's $8 per visit after the first 5. So it's 8 parentheses, they said V for visits. If you used X, you'd get the same thing. X minus 5 here, V minus 5, and then that 125 for the initial enrollment. And once you get the equation, then it's just solving through. Okay, so no solution. This would be an extremely kind of annoying problem that I'd probably wait till the end to do. So check down, seeing which variables will cancel. So no solution means I have different constant terms on each side. So basically we want those variables to cancel out. Infinitely many solutions, the variables are exactly the same, as are the constant terms. In the case of no solution, you have different constants left on each side, and the variables cancel. So I would just kind of check down process of elimination. Basically just concern yourself with what the x's look like. If they're not exactly the same and canceling out here, with different constants, it's going to give us, we won't have what we're looking for. Alright. 18. We have Vera's on her school's track and field team. Long jump, basically she gets 5 points if she gets over the close line, 10 for the longer. Gets a total of 7 jumps. And lands x times over the farther line. So the total she'd get here is 10x for over that farther line. So the amount of time she would be to the closer line would be 7 minus x, because it says she had 7 total. So 7x times 5, that would be the best way to figure out how many total points. As we're working through our equation here again, the key idea here is x is the times over the farther line, and that 7 minus x is how many times she didn't get to that line. So it's 10 for the far line, 5 for the short line. So when we think about what our answers are going to look like here. Alright, so it's looking at our answers here.
F of x equals 10x. F of x equals 5x plus 35. F of x plus equals 10x equals and plus 5. F of x equals 70 minus 5x.
Thank you, Brad. So when we combine and expand here, we should end up with choice B of 5x plus 35. In case you guys can't tell, I'm making this video at home. My daughter wants to help, and then the dog wants to participate, and the cat is staring at us right now. So we have quite the household going on. All right. Number 19, we got Brian and Jared live in the same apartment complex, and they both bike to and from work every day. So the idea here, we're figuring out which of the following statements is true. So essentially, we're just going to eliminate anything that doesn't make sense. So key idea here is that distance of 0. That can either represent they're at work or they're at home. Basically, pick one. But when we're at our x-axis here, when we're at the x-axis, that means we're at a distance of 0. So, kind of interpreting that, we have, it takes Brian longer to bike home. No, because they're getting home at the same point, right? These intersect here, so that means you're getting home at the same time in 20 minutes. It takes Jared longer to bike home. No. So neither of those make sense because we see our intersection here is both at that 20-minute time interval. They arrive home at the same time, so they must bike at about the same rate. If we look, the slopes of these lines are distinctively different. Also, one's farther than the other, so that just wouldn't make a whole lot of sense. So then lastly, Jared bikes a longer distance than Brian in the same amount of time, so Jared must bike at a faster rate. Which makes sense. He starts at 5 miles away and gets home at the same time as Brian, who only bikes 2 miles. For this one here, we have when graphing a linear equation and y equals mx plus b, so our slope-intercept. Going through the vocab, assuming b is greater than 0, so it's a positive. Reversing the sign of b, so changing it from a positive to a negative. We think about what that's going to happen is, let's say we had a b of 2, so we're 2 above the line. Now, if we're going to make it negative 2, we're going all the way down to negative 2. So if we think about the distance of that, it's going to be actually down twice as much. So this one is just kind of visualizing that, another process of elimination here. So you actually would be moving, in that case, 4 units. If it was at positive 5, we'd move 10 down, so on and so forth. So we get choice B. All right, looking at problem 21. Linear, this is just the definition of, so linear equation, both variables have an exponent of positive 1. This is technically negative 1 because it's in the bottom. This is 1/2, square root. These both have just 1, so we're good. The squared one, pretty easy to eliminate. So just definition. Does not represent linear. Both variables exponent of 1, exponent of 1, exponent of 1. If you checked this one, you'd find that it was an inconsistent slope, therefore it's not linear. Okay, farmer's market stuff, right? So we got 30% off of 90 cents per pound. So that's this bit here. So the cost C is equal to 90 times that 30% discount, right? And that'll, or just times 0.7, either way is cool. If it was increase, it'd be plus here instead of minus though. And then that's per pound. And it says the cantaloupes are $3.50 each, and we bought 2 of them. So it'd be plus $3.50 times 2. If you guys are looking for a more in-depth review of these like different word problems, I can point you into the right direction. We actually cover a bit of this in Algebra 1. It's been a while, so it might be kind of a review for you guys, or at least reaching back, but I can definitely link you to some good resources there as well. Okay, for this one, paintbrushes cost $1.50 each. Canvas is 6 times that much. Kind of moving forward a bit here, the key conversion there is just the 150p for the paintbrushes, and then the canvas, we called it C, so 6 times 150 would just give us 9. Okay, we're thinking here, what does this value represent in the equation, right? So it's a slope. It's next to our linear variable. So the local impact fee wouldn't make sense because that'd be like a one-time cost. The market value, no. The total, no. The idea here, the amount of severance tax is a percentage. That's the one that kind of gives us the most ideal thing here. So reading through the problem shouldn't be too bad. So knowing all our vocab that deals with slope versus y-intercept is pretty important. Okay, solve. Like that's really all I got for you on these ones. Again, if you guys need some review on solving different stuff, I have about an hour-long video that goes through just writing equations, solving them, and all the different work with that. You know what? Let me go ahead and throw that little note here for myself. I'll put it in this folder. Add in solving video to this folder! Exclamation point. So that'll remind me, just kind of throw that in there for you guys. I'll just call it a solving and writing review or something like along those lines. Okay, going on to 27 here. Again, just vocab, what does it represent? So if we read through this problem here, the key idea is it's a flat fee, it's an upfront cost, it's a basic. We don't use the word per, we don't use for each when we talk about a b or a y-intercept. So we can kind of get through that one. 28, we're given this graph here. It just says what's the slope. So we're just counting it out, right? So we know from left to right, it's decreasing, it's going down, so it's a negative. Down 2, right 3, so negative 2 over 3. Here, we're solving for n, so just to kind of work through the gist of it here for you. So remember, distribute, so order of operations, combine our like terms, both sides there. And then just go ahead and multiply the 4 over, multiply the 6 over, clearing out those fractions. We'll get a solve from there. Alright, looking at problem 30. So we're saying, what could it represent? They tell us how much it can do per day. So, kind of just thinking about how you go from one number to the other here. If you're talking about days, maybe you want to know how many hours there are. So again, we can kind of knock this down to an hourly print rate, because that might be interesting if I was running a printing press, right? I kind of want to know how much I can crank out in 8 hours. So depending how long I kept my shop open, how much productivity could I have, because we're probably not going to run the place 24 hours a day. This one kind of challenge is just more so saying, like, if this is really another one, I'd go process of elimination here, right? Which ones make sense, which ones don't. Alright. Breaking even problems, I definitely have a lot of good videos if you're a little rusty on these ones. Key idea here is you're going to have 2 types of equalities. This is some of that laser tag problem we talked about. So it's $80 wholesale, fixed monthly expenses of $3,600. So fixed means no variable. Each surfboard gets an X, and then here we sell them for $120. So if we set those 2 equal, we can kind of figure out the value of X there, how many we need to sell. Alright. So the following most likely represents the number of people attending the party. Okay, so we had a flat fee, so that's like a B. And then a per person cost here, so that would make sense that the $11 per person, right? So X would be our per person value. If we're looking at for a number of variable, we definitely don't want to give those constants. It's always going to be one of our X or our Y there. So in this case, Y would be the cost. X would be the number of people. Undefined slope, that's vocab, right? So y equals some number is going to be a horizontal line. X equals some number is a vertical line. It's like an asymptote for our advanced algebra units, right? Again, that's just kind of, it's a vocab question. You either know it or you don't type thing. Okay, here we go. 34. If the question, or if the equation of the line shown in the graph above is written in the form y equals mx plus b, so we've seen that like 1,000 times already, right? Which of the following is true? So it's definitely negative. It's going down. And b is positive as in y-intercept, right? So the only one that really makes sense here is b, right? A negative slope and a positive b. So just knowing our equalities, right? This means less than. If you remember, it looks like an L. By default, you always know them, right? Less than is the closest thing to an L we're going to get. The other way is greater than. Okay. Which of the following scenarios could be supported by the graph shown? So not a whole lot of information here. So that's my indicator. Think. You got to reason your way through, right? So let's take a look here. As the algae content in a lake decreases, the number of fish decreases. It doesn't make sense. Like, algae is usually pretty healthy for fish, right? Some of them eat it. The bigger fish eat the smaller fish. You know, Darwinism, right? So nature, natural selection. That's kind of, it's a sciencey thing. You'll notice in the math section, sometimes they do throw in a little bit of science stuff, just kind of like the critical thinking skills we've learned. As the algae content in a lake increases, the number of fish increases. Well, that wouldn't make a whole lot of sense because this is a negative line, so there's no way both things could be increasing. Here, and also this one says decrease, decrease, right? That wouldn't make sense because this is going up as this goes down, so they're not making sense here, right? Going to this one. As the algae content in the lake increases, the number of fish remains constant. Well, constant means there's no slope, so can't do that one. So this one here is the algae content in the lake increases, the number of fish decreases. Well, maybe this one might make sense, right? Because it's going up here, so algae content going up, the number of fish going down. So, kind of reasoning our way through it, right? We said this one didn't work because this is saying decreasing, decreasing. So if things match, if they're both decreasing together, we'd see a different slope here, right? So if things are going down together, it would actually look like a positive slope because both would go down together. If it was both increasing, we'd see it going directly up. So we need one of each type here. Constant remain flat. So again, in our case here, is the algae content in the lake increases, number of fish decreases. Interesting fact. But again, the key vocab we're looking here is the increase, decrease, right? So essentially if there's too much algae in there, maybe it drowns out some of the nutrients, maybe it takes up some of the environment, whatever it may be. Again, they're not going to hit you. They're going to hit you with like some science stuff. Basically, you know the content a little bit, but it's not going to, you know, pull back. You don't need to know the equation for photosynthesis type thing. Okay. If the values in the table represent a linear relationship, what is the missing value? So here, we know it's linear, so let's find m. Pick an ordered pair, and another one. We find our slope, pick any ordered pair, find our b, then we plug in our 9 and our y to get that question mark, that y value. This is kind of a multi-step problem, so we need to get our m, write an equation, and then substitute to find it. So not terribly hard, but it might take a few steps. Definitely kind of look through the work in the back of the book there. Alright. What was the initial amount of fuel in an airplane's tank in gallons? If there are now X gallons, Y gallons were used for the last flight, and 18,000 gallons were added when the plane was refueled. So the equation here, we have X is the now, I called A our initial amount, is equal to our initial amount minus Y gallons, and then plus that 18,000, right? So if we solve this for A, essentially add over, subtract over, we get our choice A. Okay, another one here. What is the value of H in the equation above? It's just solving. It's a multi-step thing here. Again, we kind of noticed it's not guaranteed to be a calculator question. So if you're rusty on those fractions, again, talk with me. I can provide you with the resources for that. It's just practice. If you don't practice them, you're going to be rusty on them, right? That's something right there that I would wait till the end for. If this was high school me, I'd see this problem, I'd say, okay, I'm doing this one at the end. Let me go find the other ones that I know I can do, that I can get done quick, get correct, and then I'll come back to this one, maybe work later on. All right, question 39, we have our graph here. So we have the federal government in the United States has the authority to protect spies whose species who have reached dangerously low levels. So endangered species, right? The graph above represents the expected population of certain endangered species before and after a proposed law aimed at protecting the animals passed. Based on the graph, which of the following statements is true? All right. So, pre and post, right? Pre is our solid line here. The dash is our post. So the pre is the projection before we pass the law. And then the post, we kind of go here and we see how it's not decreasing as rapidly, right? So the slope's not as steeply downward. So it's not going to make it increase, but we think it might curb a bit or slow down how fast it's decreasing. Alright, so we definitely don't want to accelerate decline in the population, and the slope's getting less drastically down, so it's not accelerating. Expect it to stop and reverse? No, it's still going down. Expect it to have no effect? Well, that would make sense. They'd be the same line then. And then choice D, kind of what we said here. Makes the most sense. Question 40. Alright, so dealing with fuel efficiency here. We have which graph could represent the fuel efficiency of an efficient car E and a less efficient car I. So less efficient, in our vocab here, as many of you know who drive cars, when gas is expensive, it really is not the funnest thing to have a larger, more fuel-consuming vehicle. Luckily for me, I have a tiny car, so I always have fuel efficiency on my side. So, if we're looking here, our less fuel-efficient car is I, so that means over the same distance, it's going to be using more gas. So we can see that that first one there is actually the only one where it shows I consuming more gas than E. Alright, 41. It's a grid-in question here. Again, it's just solving with decimals. A good strategy there, if you really don't like decimals, is you can multiply this. So each of these has 2 decimal places. So if I multiplied everything by 100 on both sides, that would clear out those decimals. Maybe make the equation a little easier, or less confusing, or more similar to what we're used to. Here, for what value of y does the graph of 3 over 2y minus 2x equal 18 cross the y-axis? So crossing the y-axis represents the y-intercept. So here I'd want to get this in slope-intercept, or y equals mx plus b form. So what I would do is add 2x to both sides, giving me 3 over 2y is equal to 2x plus 18. And then I would multiply both sides by the reciprocal of 2 over 3 to cancel out. Or you could multiply both sides by 2, then divide them by 3. It's going to mean the same thing. And we get our y-intercept there, our constant term of 12. Not sure if you could hear my daughter, but as you can tell, she's talking about doggy treats in the background, which my dog has now had about 100 of. Alright. Last bit here, we're going to go through some Chapter 3 stuff. So this is our systems that we talked about in class. Alright, for our first one here, we talked about this one together. Basically, you got to check the scale. So we move 1, 2, 3, 4, 5 units to get to negative 10, or 5 to get to 10. So it's a scale of 2. So this coordinate, our intersecting point, or the solution to this system, is at negative 6, negative 6. We add them, we get negative 12. Alright, this one, I did show the steps here of our elimination process, and again, I'm going to provide you guys with some more resources on that as well. Let me throw another note in here. Get elimination stuff from advanced algebra videos. So I'll toss that in there as well, just to kind of give you guys a summation of all the solving things. That's an advanced algebra unit, not sure if you guys got to it yet. Maybe second semester. I haven't taught the class in a while, but I'll throw that in there. Okay, so I'm just kind of going through solving. We did this one together in class, so again, use it for what you will. We talked about this one as well, so kind of reasoning our way through it. Again, this is a vocab type one. For number 3, again, vocab. Number 4, we just talked about kind of plugging in here, so not a terribly challenging problem once we kind of get through it there and finding that k over h. So again, just make sure you read what the problem wants you to find. Alright, looking at number 5. So our word problems, I called sofa S, and it said 3 times less than the cost of the chair, or 50 less than 3 times. So 3 times represents 3 times C, that's what I called my chair, is C. And then 50 less would be subtracting, right? Then we could substitute that in, since it's already solved for S, because we're told that the total cost together is 650, and solve. So again, writing the equations as well as being able to work with them and solve them. In systems, we want our kind of 2 methods there of either substitution or elimination. Here, no solution, so we need to get to the same slopes for y equals mx plus b. Again, this is another kind of like plug and chug type one here, so maybe solve both of those for y, and then see which one's going to give us the same slope, because we know we need the same slope for a no solution answer, right? Parallel lines have no solution. This one, so I called my 8 packs X, and then my number of 12 packs Y, so it says I have 54 packs of plates, right? That's that first part, and then to get the total plates, the 8 packs would be 8 times X, and then 12 times Y for the 12 packs to figure out how many of each there are. Since, I should say 496, sorry, my handwriting wasn't the best here. So I'd say this should be 496 from here. Then we could isolate either X or Y, plug in and solve, and we'd be good to go there. Same thing up here. So if the system have linear equations above has infinitely many solutions, that means they're the exact same one. C is a constant. What's the value of C? So we need to find a way to get these to be the exact same thing. So maybe what I would do is kind of clear out these denominators here. So if I multiply them both by 2, kind of see a way I can get these to be exactly the same value in both. So again, it's just setting them equal, solving for C type things, substituting. We want them to be the exact same equation. The y coordinate here is the solution. We check our scale, right? Pretty easy problem. It's by 1. The intersection there is 6,3, so the y coordinate is just 3.
If 2x minus 3y equals 14 and 5x plus 3y equals 21, then what is the value of x? Any questions?
Sure. Try reading.
Minus 1, negative 1, 0, 7, over 3, and 5.
Okay, so with this one, what we would do here is we isolate a variable, or we could set up elimination here. So I could write 2x minus 3y equals 14. Then below it, write 5x plus 3y equals 21. We see our y's are the same number, one positive, one negative. So those can eliminate without any alteration to our problem. So when I add down, I'd have 7x is equal to 35, and we could solve through there to get x equal to 5. So when we're given those equations in standard form, like we talked about in class, where it's like ax plus by equals some constant c, when they're both that way, oftentimes elimination can be the quickest. If they're not both that way, so if something's already solved for a variable, then substitution is usually just as fine. Alright, here we have, at a certain movie theater, there are 16 rows, and each row is either 20 or 24 seats. If the total number of seats in all 16 rows is 348, how many rows have 24 seats? So this is real similar to what we did in question 7, right? These are consistent types of problems you'll see is write the equation, solve. Again, if you're rusty on this, I'm going to provide a kind of a comprehensive video here for writing equations, so we can work through that. But actually, let me throw that one on my notes as well. Okay, got it. Lots of videos, lots and lots. So we have our total seats, or our total set of rows, so x plus y, and then our 20 versus 24 seat rows. Pick a variable, solve for it. You can use substitution here if we solve for x or y, or we could use elimination. Either way is cool. For number 12, it's okay, sweetie. Alright, she was saying, bless you. I sneezed really loud when I paused the video. Okay, so this one here, we have the tables above represent data points for 2 linear equations. If the equations form a system What is the x-coordinate of the solution for that system? So, first we need to write equations. So the steps for this one I kind of outlined here. We write y equals mx b for each, or y equals mx plus b for each, then solve. So I would find the slope for each of these. So pick two ordered pairs, find the slope. Pick any two ordered pairs, find the slope. I'd suggest using things like n in 0 or smaller in magnitude or absolute value numbers. They tend to just be easier, less likely to make a mistake. Especially if this was a no calculator question. Since there isn't a calculator, it means it's possible, right? You want to be able to make sure you minimize the chance for unintentional error. Then when you find those y-intercepts, then we could set them equal and solve. So this would be like a really kind of a, not necessarily a super skill-heavy problem, just a multi-step one showing the attention to detail. And we should get 8. Right. And that is it. So I'm going to go ahead and load this video up now. And then, like I said, I'm going to post a bunch of videos. So I'll try to title them accordingly, like whether it's systems or linear, writing equations, whatever it may be. Make sure you're reaching out with questions. Again, just at me on Twitter, J_CIOLKOSZ. Mr. J. Ciolkosz, but the last name's tough to pronounce, so Mr. C's cool. Hopefully this has helped you guys. Again, do as much as you can. Just do it in bits and pieces each day, and you'll be good to go for this thing, and at least in a better spot than you are now.